ready?
Yeah, sure.
You have no other option.
Yeah.
So you better be.
I'm already here. Of course, I'm ready.
Rock it.
So, hello everybody. I'm Artur, embedded systems engineer, founder of PenEngineering, and today I want to discuss with you about running containers on a 128 kilobytes device, Atym and WebAssembly. Okay, for example, you understood everything nor Atym or WebAssembly. So, I'm here with you to explain how we can change the future of embedded systems and how it can be done with open source projects. Because I love open source projects, and I love that so many developers and such a big conference is in Moldova right now. So, when we're done with the boring introductions, let's go and dive into the topic. Imagine yourself that I can run free containerized applications on this small guy. Including the operating system, it has 72 kilobytes of memory. Does anybody worked with Docker containers here? Okay, do you imagine to run free applications, Docker applications, on a 72 kilobytes of memory? Okay, when I heard this, being an embedded system engineer is like writing very low-level code, knowing the memory size, the page size. I was like doing some stuff on a BMW project with 0x08, blah, blah, blah stuff, when I need to know the actual memory address where I should write my application if I need to update the application. And when the guy from Atym, the CTO, Steven, said me, let's go, we can develop and we can deploy it with only a JSON file, a manifest file with name, and it will be sandboxed. No bus faults, no hard faults, no low-level stuff. All the drivers will be in the runtime. I was like, that's crazy. I can't believe it. So, why I believed it at that time? Because, firstly, I believe Steven. The second, from the 2023, when the market of IoT was like 1 billion, to 2025 Q2, the market of IoT started 10 billions. And Qualcomm, Intel, and other big manufacturers, they want to create and develop IoT. And the biggest pain all over my journey and all embedded engineers. Do we have embedded engineers here? Yeah, you know that pain when you should rewrite the driver if you want to change one chip. For example, on the BMW project, when we got from one architecture, from one Renaissance chip to another Renaissance chip, like, for example, from Intel i5 to Intel i7, we had to work like 9 months only for this, for one chip. And that's not the business logic, that's not the logic layer, that's only drivers and the stuff that should be and is meant to be reused in code. So, you see the punchline. I tried to write it. What if embedded software worked like cloud software? So, what if I could work only on the logical layer, only on the business logic of the device, and was not meant to be a lot of development oscilloscope like some logic analyzers? That sounds like a dream, yeah? Do you believe me? Not yet. So, let's go. The problem with chips. So, for a manufacturer to develop an IoT device, for example, we want to develop a thermostat. I will go a lot with thermostats right now. So, what we should do? We should do the hardware, we should do the software. The software, what a thermostat do? Takes the data of temperature and adjusts the temperature, sends some commands to some heater to give more heat or less heat. So that's actually not so hard to write on a logical level of this application, right? But here comes embedded systems development, which is you should have the SPI, blah, 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 stuff that is too technical to explain right now. So this is a monolithical firmware, like the guys written in C in 90s Today is 2025. We are writing it in the same way. So we have a solution. Atym, WebAssembly, and Zephyr. Does somebody heard of WebAssembly? Of course. Of course. And the standard WASI, which is in web. Yeah. A year ago, they pushed WAMR, WebAssembly micro runtime with support of C language. So, in the Atym runtime, and Atym runtime is divided to OCR, Open Containers Runtime Environment. You can find it on LF Edge, Linux Foundation. We tried to create a runtime in C language that we can just deploy the WebAssembly application to a ESP32 with 72 kilobytes of memory. So, does somebody heard of Zephyr RTOS? If you are an embedded engineer, check it out, because you really can change one config and compile the same program to different chip architectures and different chips, even from different vendors. I was shocked when I saw this. So, taking these three together, we created the OCR, and why it is different of OTA and the solutions right now that are on market. For example, right now we can update these solutions. We can update everything on an IoT device, but this is over-the-air updates. Like, for example, Amazon pushed an IoT device, and after 2 months, they blocked a function of this device and said, pay me money, please. And for this, we should, as I said, we should have a lot of stuff developed. But right now, why should we deploy a C binary, C compiled binary, if we can compile a WebAssembly, any language actually? If somebody wants to go with embedded but is afraid of hard electronics and hard stuff, with this technology, with Open Containers Runtime, you can take any PCB with a microcontroller, flash it, and write a code in Go language, JavaScript, Python, and it will work on a microchip, which sounds crazy. So the differences between the old one and the new one is that we have sandboxed execution, so no hard faults anymore. It will work, and even if it crashes, it will not burn your house. Did you hear about Samsung burning? Anybody? So you can, when you have a hard fault or a fault in embedded software, it can actually burn something physically, and that's crazy. I don't understand why we're in 2025 the first time when we get something like this in embedded, because before this we were like in 90s developing low-level stuff. So this is the comparison of Atym runtime and traditional containers, and the architecture, how we can work with this. So for those who want to try it, we have the Open Containers Runtime, as I said, and I started my own open source initiative. So you can write with an SDK or application in any language, compile it into a WebAssembly binary, deploy into the Atym runtime. Atym runtime handles everything on the low-level stuff, the drivers, all the stuff, and provides you only the API, like turn on the LED, show something on the display, and that's all. No need to go with the data sheets and so on. And how it helps the manufacturers. A practical example about the same thermostat. So, as I said, we have to develop a lot of stuff, and if we, at some point of development, want to change the MCU, the microcontroller, we'll have to change pretty everything on the side of drivers, on devices. Like, imagine yourself, you have to rewrite the Linux. That's crazy. Having the Atym runtime on our IoT device will help us. We should change the chip, reconfigure the configuration of Atym runtime, flash the chip, and deploy the same application, the same logical layer on this chip. And this would help us a lot. You can see in the example, container.yaml example, this is how you deploy the application. So no need to configure OpenOCD, the USB port, Pico.com, and other hard stuff that I don't want to remember right now because I'll have nightmares already. Implications to the new edge era. Why right now is the time to work with this? As everybody knows, we have AI revolution right now. Everybody is speaking about AI. All startups starting right now have AI. But this can be a silent revolution because deploying an AI language model on an embedded device is too much. But do somebody uses an embedded device? Okay, but embedded devices are everywhere, and I can assure you, in a week, you use or interact with an embedded device 100%. Like smart home, smart cities, your CarPlay, the system that helps your car to know how many fuel you have, and all others, all this are embedded devices. And for example, we have here some smart counters of humidity and temperature, and they, each 5 microseconds, are sending something to the server. That's pretty a lot. Why we can't just have a language model on this stuff? It analyzes everything and sends only the analyzed data to the server, only the needed, because we don't know how to put AI on the embedded device. For example, the WebAssembly initiative is open source stuff, was powered by Intel, and Qualcomm, nearly yesterday or 2 days ago, both the Arduino. And they are starting and developing a lot how to use AI on a small constrained devices. So think about that Meta Ray-Ban will be able to speak with you and to help you with everything, not just to show some information from your phone. So imagine that if this works as we expect, and Qualcomm goes with this further, the Meta Ray-Ban don't need a phone. They are like another phone for you. So you use them only for this. And why this is important? Because having a phone, having a laptop, that's very cool. But we need right now, and every manufacturer, and you see this news, that we want small devices that can fit everywhere, and we want to have AI in there, of course. AI is important, of course. And we have here a lot of developers, but only one developer said he's an embedded developer. Do you think you can't write a logical layer, or all other developers, not you, do you think you can't write the logical layer of an IoT device, like to take the data, to analyze it, and to send it to the heater? Everybody can do this. The problem is the drivers and all other stuff. What if we have one developer, one embedded developer, to configure Atym runtime and to flash all our devices? And other developers that have an idea can just write the application layer, and all the devices will work. And we don't need 500 teams of hardware and embedded engineers. We need one good embedded engineer and a good engineer that can write in Rust, C, Go, and other stuff with WASM APIs. Even if you need some API that is not available right now, that's not a problem. You just take the WASM, take the runtime, because it's open source, and add the APIs you need. Or ask your friend embedded engineer to add them. So this will change the market a lot, because that can give us faster time to market impact, flexible and secure software. Because, for example, a hacker got the router of like Wi-Fi router, and with a simple USB got the data, because there was no security for UART protocol. Actually, he got the soldering gun, soldered 4 wires, and got the data from this Wi-Fi router. That's crazy because in our days, because having a Wi-Fi router, just knowing some soldering and knowing some embedded stuff will change how will give me the possibility to hack every Wi-Fi router? Right now, not, because they fixed it, but I assure you I can find a way if we don't have a real-time operating system there, if this is a standard monolithic way of development of embedded. So, as I said, we have Ochre project. Anybody who wants to check it and try it, we have LF Edge. Ochre project is a part of Linux Foundation Edge. We have Zephyr project, which is a best RTOS I saw in all my career. Atym, the embedded container technology. And on the link, on the QR code, I have all the links. Also, I have their Akira project, my open source initiative, because I wanted to test what I can do with Ochre. That sounds so cool that I needed to have a hands-on this technology. So everything is available on GitHub. If you want to discuss something about Akira, Ochre, Atym, Zephyr, I'm open to discussion. And even if you don't have some embedded low-level knowledge, that's not a problem, because this technology and these open source projects are open source right for you, for not to be an embedded developer, just you to be able to change this, to try it out as any other technology, because having technologies from 90s is too much for 2025. That's why nobody is going to embedded, because going from front end to back end, it's not so hard. But going to embedded, oh, I have to know physics, I have to know some stuff. But no, right now, this technology will change the world and will change the future of embedded systems. Thanks a lot.